first time we're going to talk about is introduction. So this is really easy, straightforward. So most of the things, the way that I do it, so you understand the pattern, I follow a pattern, it's easier to find out a pathway, is that as I cover the class, I give you the objectives or the topics or the links that you need to learn for the test. In other words, as I mention something, hey, this is going to be on the quiz, or this is going to be on the test, or you see that I cover it 2 or 3 times within the same lecture or during the whole semester, guess what? Most likely, like 90% of the time, you will have a question on that. Does that make sense? So the first thing we're going to do is we're going to define what anatomy is and what is physiology, okay? And I'm going to explain how they're related. Name and difference between all of the levels of organization. So in other words, it's just 2 definitions and know the levels of organization and how do you actually see them or apply them in the real life, okay, through this section. So what is anatomy and physiology, right? So they are complementary to each other, means one depends on the other one. And they're branches of science and that helps with the human body, okay? So anatomy means what? Internal structures, right? And physiology is how those internal structures interrelate within each other at the smallest level. And the smallest level that we have as humans, and everything has the smallest level, and that will be what the smallest level you think that will be? Cells? How many of you agree with cells? Why? It's okay to be wrong. Yeah, I'd rather you guys being wrong in the class than being wrong on the quiz. But the more you participate, the better it is for you. Right. The smallest structure is not a cell. It's the stuff that makes up the cell. What is the things inside the cell? Since some of you, organelles, right? So there are organelles, right? Smaller structures within the cell. But the book doesn't go into much in detail. As a matter of fact, when you see me showing it to you, they don't go a lot of details into how the organelles came about to give rise to a cell. They don't go into the details. There's a hypothesis, but it hasn't been proven yet. Now, there's something even smaller than organelles, which is what? The molecules, the compounds, right? The electrons, the protons, the atom, right? And smaller than the atom are, well, the electrons, the protons, and the neutrons, right? What makes up the atom, subatomic particles, okay? So those are the really, really tiny, smallest ones, okay? Am I going to ask you that detail? No way, okay? I gotta go by your book, I go by your book. But I want you to understand what that means, right? So, anatomy, study of internal and even external structures. Physiology is how everything gets performed, right? And the functions of each one. So how everything gets interrelated. So if you have to understand that there is no a functional anatomy if there's no physiology behind it, okay? As every single human being that you are or that you may meet, okay, they have to have a connection between one cell to the next cell. If a connection is lost from one cell to the next cell, or one tissue to the next tissue, or one organ to the next organ, or one of your systems fail, then you most likely will develop a what? A disease, right? A failure. A failure of the cell, failure of the tissue, failure of your skin, right? Which can give you cancer, it can give you an ulcer, right? How many of you have ever had an ulcer in your life? You guys know what an ulcer is? Yeah, I mean a regular ulcer in the skin. A papule, which is a raised, like a first-degree burn, right? A first-degree burn, how many of you had a first-degree burn? If you don't know, it's just a raised filled with a fluid, okay? That's called a vesicle, right? So the little papule is actually hard inside. But that little vesicle is a first degree. That means you have damaged what? The cells, right? And the tissue with the skin underneath. Does that make sense? Now, if there is proper connection or interchange, right, of energy and electrolytes and oxygen and nutrients, then that skin or that tissue that's affected most likely can go back to what? To normal. And we call that regeneration, right? So most of our tissues, and we have the capacity to regenerate. Imagine having the capacity to regenerate not ourselves only, but our clothing, our cars, everything in life. That would be great, right? You laugh, but imagine something like that. Imagine you crash the car and the car will automatically fix itself. You know how much money you'll save, right? Imagine somebody cuts a tree and the tree grows itself. Have you ever seen that happen? Guys, all the time. Trees can grow back, right? You know. I mean, if you take it out of the roots, no. You know, it's like you take the heart of somebody. But normally, if you cut a tree branch, then the tree will just send another branch, right? What about your tires, right? What about your money can auto-regenerate? Okay, that would be great. They call it what? Passive income. I mean, that's a joke. Anyway, so anatomy and physiology, they are close and they are, of course, integrated, right? Both theoretically and practically. So, what is the link between them? They are physiological mechanisms, okay? That allows for everything to interconnect. So, anatomy and physiology are closely integrated because, again, they're complementary, okay? In other words, every time we have a structure, we ask ourselves, well, why is the structure there? Why do we have arms? Why do we have legs? Why do we have eyes? What do they do for us? What are they there for? So let's ask some really simple questions. Why do you have eyes? So a structure of the eye tells you what? Or an assumption of what the function is, right? Well, the eyes to see, that's not the only thing the eyes do, right? Just to see. You think that's the only thing that the eyes do? Well, you can appreciate life. You're just putting more synonyms. You're still seeing, right? But eyes is a way of connecting to the environment. Wait, you're saying the same thing. I'm seeing, right? Well, no. If you're blind, what is the function of the eye? How do blind individuals know when there's day or night? Sensitiveness of light. So lights, even though you cannot see, your optic nerve, right, which is the cable that connects to the eye, it's obliterated, it's cut, it's damaged, whatever it is, right? You still are able to sense, right, temperature changes at the eye and light changes as well. So your body has the capacity to feel, right, and to measure things all around it. That's why you're almost a perfect machinery, okay? If you think about it, every single car nowadays, it comes with a bunch of sensors, right? A sensor, if you go reverse, right, before hitting the car, it goes beep, 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 so you don't hit it. And even though people hit, but anyway, so that's a sensor, right? You have sensors to change lanes, right? The car tells you what the gas, we're about to run out of gas. That's another sensor that is inside the tank. Your car even tells you which tire is out of pressure or it's a flat tire. That's another sensor. Where do you think they got the idea?
Human body.
The human body. We are full with sensors. That's why our body is able to accommodate, to adapt to the environment that is always changing. Does that make sense? So all specific functions are performed by a what? A specific structure. Okay? So, for example, bones, right? Bones, what is the function of having bones? It gives you some sort of like stand-up body, right? They call it structure. Imagine a life or your body without a bone. What would that look like? A blob. That's my favorite word, a blob. So you look like a blob. And how would you walk? Well, like the blob walks, right? Just, I don't know, swishing through the floors, right? So that gives you support. But not only that, it also does what? If you check your costal cartilages, right? Your thoracic cage, it protects organs, vital organs that are inside, right? So that as well gives you some sort of course, protection. It gives you some sort of rigidity as well and solidness to your body. But there's other things that they don't explain, and we're going to go into detail, and that is what? Calcium is the main source for muscle movement. You cannot move a muscle in your body without the proper amount or levels of calcium. That means that the best way to store calcium, it's at the level of your what? Bones. That's what we're talking about. So, your body, when you eat too much calcium in your diet, right, and it will store it in the bones. If your bones are full with storage of calcium, what do you do with that calcium?
Use it.
Okay. Let's see. If you have too much bananas, right? Let's say you are a banana eater. Okay? How many bananas can you eat in a day? 2. Let's make you have now 20 bananas. What are you going to do? If you don't eat in a day, you have to throw them away. All right? So you can only eat 2. What do you do with the rest? There you go. So that's what your body does. So if you ingest a certain amount of calcium daily, your body uses that daily calcium to do muscle work, right? To activate your muscles to contract and relax, so you're able to do what? Well, one of the main muscles that are important for us is your diaphragm, which is a muscle, the main muscle of respiration. Without that muscle working, you cannot sustain life. Does that make sense? Because it increases the capacity of your thoracic cage to get more air into your lungs, or less air as it pushes it out. Your heart is made out of muscle mostly, right? And your heart needs calcium. If you don't have calcium, then your heart will fail. You will tend to have a decreased heart rate, which we call a bradycardia, and to a point that your heart can fail because it doesn't have any calcium to stimulate the electrical impulse. Does that make sense? So calcium is a vital thing. Now, if you take too much of the calcium, then you have a storage portion, which is your bones. Now, if your bones are storage complete, what do you do with the excess of calcium? You throw it away. In what ways? How can you throw things away? How can you eliminate excess things in your body? Sweating. Pooping, right? Peeing, urinating, right? So all these things, or also other things, right? Like vomiting, right? Just by a simple way, you can eliminate excess of everything. And that is a golden rule. Every time, if your body is working properly, right? If the physiology of each individual cell, tissue, organ system works, then you should be able to eliminate whatever you don't need. I don't care how much you take. Let's take, for example, protein. So you can take 300,000 grams of protein. If your kidneys work, right, they should be able to eliminate the rest of the protein that you don't need. But as a side effect, too much calcium in your urine can lead to what?
Kidney stones.
If you have a little small calcium, and I give you more, I give you 1 million calcium, little tiny ones. When calcium gets together, it creates a rock. We call that a kidney stones, right? A stone. Now, if that goes into your poop, right, into your fecal matter, then what's going to happen? Well, your fecal matter, if you notice, is not rigid, not solid. Imagine passing something solid through there. As you put calcium into that fecal matter because you are intaking too much and you didn't notice that you have constipation, okay, then that fecal matter will become rigid and it will make you even harder to go to the bathroom. Okay? So far, so good? So there's a lot more thing. This is just about calcium, right? There's a lot more to it. All right. So, in other words, it also helps the muscles. Of course, that gives you flexibility and it can allow you to contract and relax. Now, what is gross anatomy and what is microscopic anatomy? You need to know the difference, at least to be able to recognize it in a multiple choice setting. So our gross anatomy is something that you can see with your naked eye. Well, in my case, with my glasses, right? But the gross anatomy is the anatomy of the surface of your body, is the anatomy of a region of your body. Can you give me a region of your body?
The head.
The head is a region, right? The arm, the finger, right? Those are regions in your body, right? In this case, they go into a head, neck, trunk, whatever. So systemic, what is systemic? Systemic is referring to a what? A system, right? We have not talked a lot about the systems, but probably the word rhymes with it, right? So cardiovascular system, respiratory system, urinary system, right? Reproductive system, right? Immune system. So all these things, right? We also have developmental anatomy. Why developmental? Do you develop? Yeah. I mean, when you were born, you were really tiny, and now you're grown up, and not only you getting bigger, but you actually getting what? Complex and smarter. And the more you feed that complexity, the more you feed your life with new information and application of the information, keyword. You can learn as much as you want to. If you don't apply it, you're going to lose it. Okay? That's 100% proven. Okay? So, you have been developed. It means, what is development? Is from the change, the time that you're being conceived, right? Onto the maturity of the individual. Okay? This is, we're talking about embryology. So, conception is what? Do you know when you were conceived? Conceived means what? Your mom and dad had sex and she got pregnant, right? All right. You don't know that. Well, they told you, but the date, but that's it, right? Hopefully. Or not that much details. So clinical anatomy. Now, clinical anatomy is referring to what? To either medical, radiographic, surgical, right? So that is what we call about clinical, right? The actual application within the medical field, right? That's the clinical aspect. Now, the next one is microscopic. The microscopic anatomy requires you to use a microscope. So it's really simple, right? And what are the things that you can see with a microscope? You can see the cell, which cyto, if you break the word, cyto means cell. Ology means the study of, right? And then the other one is histo. Histo means tissue, and ology means the study of the tissue. Okay? Now, within the physiology, there are cell physiology, there is a special, systemic, or pathological. Is that changed at all? It's still physiology, which is what? What is physiology, guys? Function is the study of the function of how things interact. Well, they're saying about cell physiology. What do you think the function would that be? For the cell. What about the special? I don't know what's special. Well, a special is what? Your cardiac physiology is in a special system. What about systemic physiology? System. So a special is just about the heart, the organ. The systemic, it's about the heart plus all the blood vessels with it. Does that make sense? And the last one is pathological. And we're going to go a little bit into that one through the whole semester. I'm always going to give you samples. That's what brings your attention. And so pathological physiology is the disease, right? When the physiology goes wrong, that's where you got patho, right? So, next one up, we're going to be covering the levels of organizations, okay, in the different organisms. In this case, we just focus on humans. So, human body is actually complex. It has how many cells? 100 trillion cells. Is that a lot? So, imagine having $1 for each one of those, okay? It sounds like a lot. So, I mean, that's more or less, right? So, each of these cells, they have what? DNA. I don't know how many times can I do that. So, of DNA. That means that each of these cells has in it, inside DNA. But what is DNA? What do I need to know about DNA? Well, actually, without DNA, there will be what? No life, no structure, no connection, no communication. Because the code that is able to send information into making new structures, connections, etc., is already pre-constructed the day that we were conceived for both mom and dad. So we got a little bit of mom, a little bit of dad. Okay? Supposedly, most likely, half of your chromosomes comes from mom and half of the chromosomes come from dad. So dad gives you 23, mom gives you 23, and you're built with what? 46. Now, can you get 47? Yeah, you can get actual chromosome, but some of those are trisomies, right? And then we have a pathology, right? We call it pathology. Now, DNA is the building block, in other words, okay? So the human body is organized in, of course, in a hierarchical manner, and this, by book, is the smallest one, right? Atoms. Again, inside atoms, what do we have? Subatomic particles. Atom, sub means underneath, right? Like subway, like underneath the way, so on the way or something like that. I guess that's what the word means. But subatomic particles means the structures that makes the atom. If you ever see something like that, highly unlikely, right? Please understand that a subatomic particle is something that is smaller than an atom, right? That is electron, protons, and neutrons. That gives rise to the chemical level, okay? So atoms are part of the chemical level as well as what? Molecules. We need to learn the difference between a molecule and a compound, okay? So, molecule, what is a molecule? How do you make a molecule? By atoms coming together, correct? How do you make a compound? How do you do that? So there is a difference between molecules and a compound. I'm not going to start going crazy. Hold on. And we're going to talk about it in about 5 minutes. Okay? Cells is the beginning of the cellular level, which is, again, the cell is the smallest structural and functional unit of the human body. That, by definition, you need to learn. Okay? Tissues, so a bunch of cells working together, right, to perform pretty much the same function. We build what? Tissues. As you get different type of tissues, can you give me an example of tissues? You have connective tissue, okay? What is connective tissue? If you're thinking too hard, that's why you're getting it wrong. Connective tissue is something that connects. Like connecting what? Like blood is a type of connective tissue because blood connects all your body, right? You have elastic cartilages, right? Inside you have connective tissue, right? So there's some type of different tissues. Now, organs. Being able to build an organ, let's take, for example, your heart. Your heart is the organ, is the organ level. Your heart is not only built by one tissue, but in your heart, mainly we said that is made out of muscle, and that is cardiac muscle. But inside the heart, you have valves, right? And these valves are not made out of muscle. These valves are made out of what? Another type of tissue. What would that be? Well, there is collagen, there's elastic tissue in there, right? So there are different types as well of connected tissues. In this case, so an organ is made out of different tissues. Let's take, for example, your blood vessels. A blood vessel is just a tube, correct? But it's a tube that is not rigid. It's a tube that is able to change. Like a blood vessel is able to do this, right? Why is it doing this? Well, when you do this, and imagine having your hand on the tip of the water hose. Can you imagine that? When you put your hand on the tip of the water hose, what's going to happen to the lumen? When you put your thumb on it, it's going to shrink, right? So now there is more water coming off or less water? Less water, but what about pressure?
It's more compressed, so it's coming on.
So it's a higher pressure, less amount of water. That's what it's doing in your blood vessels. right? More pressure, in this case will be blood pressure, right? And less amount of blood flow. Does that make sense? So it's like that. So what allows the blood vessels to do this? Well, you have connective tissues, and there are different types of tissues in there. Like, for example, smooth muscles, right, is tissue, and that is within those tissues. You have elastic tissue because they're allowed to move, right? So there's got to be some sort of elasticity, okay, within there as well. And there's also other tissues surrounding as well the blood vessels, okay? So there are different tissues within an organ. Now, organ systems. An organ system is pretty much a group of organs, like for example, the heart and the blood vessels. We call it what? Cardiovascular system, okay? And finally, if we have all these bunch of systems, right? Cardiovascular, respiratory, reproductive, lymphatic, immune, all these systems, they actually, if they work as a syncytium, means that they work together, all right? And they communicate properly, you're able to maintain and have a what? Organism. What is an organism? You are an organism, right? So if one of those systems fail, well, then you have a system failure, which is a pathology underneath that is causing this to happen, okay? So you can see here an example of atoms, right? And we have, for example, a molecule here. So what is a molecule?
Atoms combined together.
A small molecule is your water. So a molecule means what? Two hydrogen atoms, so two of the same. What is a compound? There's a different element. So a small molecule like the water is not only a molecule, but it's also a what?
Compound.
A compound. Does that make sense? Because its composite is two different things, okay? Or same. Everybody got it, right? So the two little white things are hydrogen, and the blue one is the oxygen, okay? So what are macromolecules? So molecules can be smaller, can they be bigger? Well, a macromolecule is protein. How many of you take protein? How many of you are vegetarian? Oh, if you're not a vegetarian, you take in protein. I'm not talking about protein powder. I'm talking about muscle. How many of you eat muscle? Oh, that sounds weird. Well, I'm sorry, you eat muscle. What is your favorite muscle? Steak, red meat, right? But you're able to eat any type of muscle, right? Even if you eat fish, that's muscle. Okay? That's why the protein is there. All right, so DNA, double helix. Right? That's the actual DNA in our body. It's a double helix structure. And again, that's another example of a macromolecule. So we have a group of atoms, right, that forms molecules, and these molecules brings together these molecules and our compounds, which somehow they were able to arrange themselves and create tiny structures within the cells. These tiny structures within the cells, we call them what? Well, I'm not going to do all of them. But every one of these things are known as organelles. Okay? And the hypothesis states that there's some sort of a symbiosis, right, that took place, especially this one. Our DNA of our cell that is found in the nucleus. Wait, that's not nucleolus. Right, the nucleus is the whole thing. So the DNA found in the nucleus is a double helix, correct? And it's a spiral double helix. Kind of like a staircase, right? Spiral staircase tool. Hold on. But the DNA found in the mitochondria is circular. Circle. That means that DNA does not coincide with the one in the cell. So it seems like there was two different, like a mitochondria was part of an organism, right? But your body creates mitochondria with the same circular DNA all the time. Okay? So the next thing that we're going to talk about here, well, that I'm going to say, is that you need to learn every single organelle within the cell. Every single organelle and their main functions. Okay? Don't stress. I have a table for it. Okay? So, well, we talk about the cellular level, right? The heart muscle is a cell, right? And the heart muscle has a specific structure. I don't go into much detail because we're going to talk about muscles later. But so you can hear it first time. That specific structure in the heart muscle is called intercalated discs. And let me see if I can draw something like that here. The intercalated discs, pretty much they look like this, right? You can see them here. What they have in that intercalation is that they have channels. And these channels, right? I'm supposed to draw channels like this, right? And these channels allow for ions to come across from one cell, so cell number 1 to cell number 2. Freely. So if you need sodium, automatically goes to the next one. If you need potassium, automatically goes to the next one. Okay? Have you ever lived with a group of individuals? Let's say a family. So if you live with a group of individuals, a family, and then if you need sugar in your lemonade, most likely you will say, hey, can you put some sugar? Right? That's what it is. You don't have to go to the next door. It's just a one-way stream or two-way stream. If something's needed, you give it to that person. If the other person needs it, you give it back or something like that. Okay? So that is the intercalated dysfunctions. And then of course we have the outer molecule cells, right? And then we have tissue. So what is an example of tissues, right? We talked about connective tissue, right? We also have epithelial tissue, like, your lungs, right? That is a simple squamous epithelium. We're gonna talk about that later. You have the cardiac muscle, and you can see here, you can appreciate the intercalated discs, okay? So anytime you see wavy things like that in an image or a microscopic slide, whether it's me as a lab professor or somebody else, just that is cardiac muscle, okay? So cardiac tissue, connective tissue, epithelial tissue. The heart possesses what? All of them, okay? What about adipose tissue? Does your heart contain adipose tissue?
Yes.
Yeah, I mean, you can see that on that side, right? This is all fat. Wait, do you really need fat for that to work? No, but it's there. Well, you do, so the way. Because, and again, what is fat? What do we have fat? What do we store fat? Correct. It's the proper and most efficient way to store energy in our body. But why does our body store it? Survival. How many of us are surviving right now?
Oh.
I am. I haven't ate anything since 9 p.m. We call that what? Fasting? Starvation. But yeah. We call that fasting, right? So that's what it's there for. You're able to keep going even though you haven't eaten anything in what? 12, 24, 32, right? Many hours, right? You can be a whole week without eating, you still will not die. You will keep persisting, be like, are you crazy? I mean, no, it's part of your body. From time to time, it should be a good thing to do, is like stress your bodies a little bit. Because whenever you stress your bodies, all your body's doing is what?
Using stored energy.
If you want to lose weight, yeah. Adapting. When you have the food every single day and you eat every 3 hours, your body's expecting to get every 3 hours. Imagine that one day, you don't give anything the whole day. Your body be like, what happened there? So you stimulate blood flow to the areas that you didn't know you had it. You have to. I mean, there's two things. Either you die that day or you persist. I mean, most likely, you're going to continue. You're a hard thing to do. I mean, a hard thing to kill, in other words, right? So your body adapts from time to time. All right. So the next thing, so I can cover this thing. So smooth muscle. So this is your blood vessels. So you have a smooth muscle, like I mentioned. You have connective tissue, and you have other epithelial tissues, right? So, like I said, smooth muscle is the one that allows you to vasoconstrict and vasodilate. What is that word? So vaso is your blood vessels. Constriction is closing. Vasodilation is opening, dilating your blood vessels. So when you dilate your blood vessels, there's more blood flow can go through, and there's less pressure. Do you always have the same blood pressure? And how many of you know your blood pressure? What is your normal blood pressure? All right, so let's do blood pressure now. Give me numbers. 12.8. What is 12.8?
120 over 80.
Yeah, like 120.
No, but that's not 12. That's 120 over 80. That's a zero. Zero counts. Imagine a bank account with no zeros. That's awful. So 120 over 80. Sadly, that is not where you want to be. What are you doing? That's not what I heard, and that's not what everybody's saying. What are you doing? Well, if you read the new literature that is coming out there and the new researches, for about 5 to 7 years ago, Europe had it. And Europe said it's 110 over 70. That's where you want to be. If you are constantly in 120 over 80, there's a risk of you becoming what? On the long run, hypertensive. Does that make sense? Now, what builds this blood pressure? What is the blood pressure? Think about what blood pressure is. Yeah, that's it. It says blood pressure, right? Is the pressure, the blood that is exerting against the walls of the blood vessel that we're constricting and dilating. So when your blood pressure goes high, what is your blood vessels going to do? Constrict or dilate? When your blood pressure goes high, so you increase your BP, what's going to happen to your blood vessels? Well, so you need to write blood vessels like that. They dilate. If you increase the amount of blood in the blood vessel, you have to do what? If you constrict, what are you doing? You're making more pressure. Does that make sense? When you dilate, you decrease the pressure. So you do a dilation, vasodilation, correct? All right. When your blood pressure goes down, what do? You constrict so you can maintain pressure. Why are you going in this? Well, it's really simple. It's part of you. So if you don't have proper amount of pressure, that means the blood, or in case of the water hose, right? The water does not reach the area that you want to reach. Have you ever wanted to get a farther out stream with a water hose? You end up either closing the tip or just putting your finger closer to the whole thing, right? And the stream just reaches farther away, correct? That's the same thing that is happening in your body. If your blood pressure is decreased, then all the blood is not going to get to every single cell, right? If your blood pressure is too high, right? You guys all familiar with Marvel? The Hulk?
Yeah.
Or the Hulk, I don't know what you call it. The Hulk, right? Imagine him going through the wall. Can you imagine something like that? And everything breaks, right? When your blood pressure is too high, what are you doing? You're damaging the walls, you're damaging the cells, you're damaging the blood vessels because it breaks them. There's too much pressure. When you blow up in a balloon, if you put too much pressure inside the balloon, what's going to happen to the balloon? It pops. Well, our blood vessels don't have that much elasticity that's going to blow up like a balloon, right? They have less and more rigid, but you can actually rupture it. So that's why your blood pressure needs to be maintained somewhere there. Does that make sense? So that's application. So different type of tissue makes organ. Here's another one. So you have your stomach. It has smooth muscle tissue, and you also have connective tissue, and you have epithelial tissue inside the stomach. Imagine. Can you say something to the stomach? Stomach, move. Stomach, stop. Can you? You can. So there are 3 types of muscles that we're going to cover later, and the first one we talked about, kind of implied, and that one is skeletal muscle, right? The one that we talked about was what? Cardiac muscle, and the other one is going to be what? Smooth. Out of these 3, which is the one that you can say or tell what to do? Skeletal. Because the skeletal is around your skeleton, right? Can you tell your heart to lower his beat? Heartbeat low. High, no. Right? I mean, if you concentrate, you could. If you concentrate, you could. If you get really mad, you definitely will increase your heart rate and your blood pressure. Okay? But normally, no. Cardiac and smooth, you have no control over those. Okay? And that's a smooth muscle here. So we talk about the organ system, cardiovascular system, and of course we have the different levels of organization again. Okay? So let's talk about the organ systems. So the first system that we're going to cover in this part of the class in 2085 is going to be integumentary system. Who knows what that is? Your integument is the skin. So whenever you hear integumentary system or you see it, if I say skin, what do you say? Whatever, it doesn't matter if you cannot pronounce it. All right? So if I say integumentary system, you say what? Skin. Well, does the skin comes plain? Well, nowadays people shave everything, right? So there's not a lot of hair, but then you guys know that hair is part of the skin, right? How many of you shave your nails? I mean, you cut them, but you don't shave them off, right? You don't know. I mean, maybe there is something new now, right? People always invent something new to get attention. So, yeah, you got nails in there as well. How many of you paint your nails? Right. So, sweat glands. And in your skin, is not everything is good, but not everything is bad. Sweat glands are part of your skin, which is when you overheat, how do you get rid of that heat? Sweating. Is sweating that bad? I mean, you stink sometimes, but then other times, this allows for what? For pheromones to be dissipated into the environment. And it's like you walk by and you go like, smell just hits you. And it's not a perfume, it's just the smell on the individual. If that ever happened to you? Do you have a relative one or somebody that you're close to? If you ever smell them, like once they end up, out the bath, not stinking, but they usually have a predominant smell. Every one of us has a distinctive smell. And these are pheromones. When are pheromones the highest? Okay, in female dogs, I don't want to say that name, but female dogs, they give pheromones. And that's how the dogs know that she is menstruating in heat, right? Females, as they get close to their menstrual cycle, right, to the end of the menstrual cycle, they release what? Stronger pheromones. What about guys? We do release them as well. Do we have menstruations? No, we got fluctuations as you do of hormones, but we do not have menstruation. Right? So, functions. Protects against the environment. I mean, if you have a skin, it's able to regenerate, right? What better clothing do you have than your skin? Is there any other clothes that does the function of your skin? No way. That's a perfect clothing. It's able to regenerate, and it's able to prevent any hazardous material, chemicals, or anything that go inside your body, right? The skin will take the hit, and it will regenerate. Now, helps regulate body temperature, as we mentioned, through the sweat glands. It provides sensory information as well, right? Sensations is what? What are you able to sense in your skin? Tell me. Touch? Temperature? And?
Physical.
Pain. So, pain, touch, and temperature. These three things you're able to sense. But within touch, you got different touches. What are the touches? You have a light touch, and you have the poking one, right? Which is a deep touch. So those are the things that you always, whether you like it or not, you feel it. Right now, I'm pretty sure that none of you are thinking of this until I told you, which is the touch of your clothes in your body. Can you feel it now? If you concentrate, you can feel it. Normally, you don't even pay attention to it because your body is somewhere else and you're thinking and you're concentrating on something else. So it kind of takes that off, right? You lose concentration. But you can feel it.
Also, the tongue, when it's in your mouth, you normally don't feel it. And when you cough it.
Yeah, when you think about it, you become conscious of it, you feel it, yeah. So levels of organization. The next one is the skeletal system. And this is the bone, right? Bones, bone to bone, what do we got? What is the glue between a bone and a bone? A cartilage. So there's a piece of cartilage between a bone and a bone. Whenever you lose cartilage, what happens to your joints? Well, your joints are going to pretty much decrease in size. You decrease in height. Since your joints are you getting older, in other words, right? You're losing inches. But normally you get bone-to-bone rubbing, and this will lead to what? Arthritis, right? So there's two types of arthritis mainly. There's osteoarthritis and rheumatoid arthritis. Okay, we're going to talk about that later. So associated ligaments as well. What do we use ligaments for? Well, ligaments is what connect a muscle. So this is a muscle, guys. Take my word for it. Right? To the bone. Okay? Ligaments is bone to muscle or muscle to bone. Can the bones move without muscle? Can the bones move without muscle? Can the bone and the muscle move without ligament? If you torn a ligament, can you move the muscle? The muscle will move, but it will not move the bone. Does that make sense? If you have a torn ligament, yeah, good for you, or bad for you actually. But you won't be able to move the joint, right? Most likely. I mean, unless the joint has multiple amounts of connections. Now, the next one is bone marrow. What is so important about bone marrow? So, bone marrow is, I take my word for it, that's a bone. The marrow is the inside. Have you ever eaten the bone marrow? If you ever had a soup with bone inside, most likely you have gotten the red stuff inside. Or the one we like most is not the red color one, but we like the white or yellow. So bone marrow comes in two colors. It could be what? Yellow or red. The yellow bone marrow is just what? Fat. Okay? If you ever had oxtail, right? If you did that on the actual inside, well, that's what you're doing. So the yellow is just fat. It's just energy there, right? Just storage. But the one that we want to learn is the red one. So the red bone marrow has 3 cell lines that are able to be synthesized inside, so they can make 3 cell lines. What are those 3 thread lines? Well, if you know the colors, it's easy. So we got white, red, and platinum. The white is for what? White blood cells. The red is for what? Red blood cells. Guess what these cells are?
Blood cell.
They're in the blood, right? So the name is white blood cells because they are in the blood. What are they? Cells. What color? White, or mostly white, or somewhat white. They're not truly white, but so the red blood cells, again, they are red, they're in the blood, and they're cells. And the platinum ones, well, I call it platinum, but it's actually called platelets, right? So platelets, what is the function of platelets? To prevent for bleeding, right? They form platelets in conjunction with other structures like fibrin, calcium, coagulation factors. They form your blood clots, and that's what prevents you from losing all the blood in a single cut. If you don't have platelets in your body, most likely every time you cut yourself, you will be bleeding and bleeding and bleeding for days and weeks. Does that make sense? If you have any deficiency of the coagulation cascade factors, then you will be bleeding for decades. Okay? Now, the red blood cells, what do they do? What is the function of red blood cells? Transport oxygen. Is that the only thing they do? No. What else they do? No. No. That's the blood, not red blood cells. Guys, the most important thing that everybody forgets. They don't transport only oxygen, but they also transport what? Carbon dioxide with the highest affinity. Okay? So, transport of oxygen and CO2. So far, it's good? Now, you as a body or as a cell, individual cells, every single byproduct of a cell ends up in one way or the other with CO2. Almost all the time. How do you get rid of the CO2? Well, you have to bind it to the red blood cell or ship it into the blood so it can go to your lungs and you breathe it out. Does that make sense? White blood cells is part of your immune system, right? It fights against any foreign pathogens. So now you know those things. So provide support and protection. Why support? If you give oxygen and CO2 to your body, I mean, that's supporting, right? if you have white blood cells that fight infections or platelets that prevents from bleeding out, it kind of gives you sort of a both support and protection, right? Store calcium, we talked about the calcium, right? And the storage of it. And the forms of blood cells, well, we talked about that, okay? Actually, there's 3 cell lines. Then we have muscles. We have skeletal muscles. And again, muscles are in conjunction with what? Tendons, right? So tendons to muscles, ligaments, bone to bone. Now, the functions of the muscle is to do what? Mainly movement. But as you move, the more you move, the faster you move, the stronger you move, you create what? Or you generate what? Remember, the first law of thermodynamics says that what? Energy cannot be either created nor destroyed. So whatever energy you use in your body, let's say you're eating up your adipocytes, right? Your chichos, right? Your adipose tissue, or your love handles. As you eat that fat, right? The fat gets converted into energy. That energy is a form of ATP. We're going to talk about that later. But as you break that energy, energy has to go somewhere else, right? Again, you cannot do what? Create it or destroy it. You just shift it, right? You change it. So now it was in a fat. You make it into an energy molecule, ATP. And as you use it, now it gives out what? Heat. Okay? So all you did is use and transfer the energy. But the energy is there. When you die, your energy will stay within Earth. What? Yeah, when you die, isn't your tissues have energy? Doesn't little critters on Earth, they feed out of you? And you are really good what? Plant what? Fertilizer. You're a good plant fertilizer for Earth. Right? A plant will grow, gives more fruits we'll be eating. I know that way it looks gross, but that's what's been happening for millions and millions of years, right? I think so. Unless you get cremated and your dust goes away. But again, it goes into heat. All right? So, protection and support, and it generates heat as maintaining temperature. Okay? So the next one is your nervous system. Nervous system, again, nervous system is divided into your central nervous system and your peripheral nervous system. The central nervous system is composed of your brain and your spinal cord. The peripheral nervous system is everything else. But the one that dictates almost everything that is happening within your body, which system would that be? All the systems, right? Nervous system. But yeah, central. Does that make sense? So your nervous system is the one that commands everything else. Again, all the electrical impulses, everything, information that is being picked up, the pain, touch, and temperature, any sensation of light, pressure, I don't know, whatever that you picked up, blood pressure differences, all that is interrelated with your nervous tissues, okay? So brain and spinal cord, peripheral nerves, and sensory organs, okay? And then sensory organs, you have your special senses, right? What makes you special? Your special senses. So what are your special senses? I give you a weird word and now you don't know, okay? Why are you thankful for? Thankful for?
Taste.
Taste. You can taste.
Smell.
Smell. Can you smell? Yeah. What about you guys?
You can see.
See, hear, touch, feel. So those are all your special senses. Okay? Imagine a life, imagine a day, well, you can imagine it because you've been there. Imagine a day without being able to taste properly. And be like, you're weird. No, I'm not weird. I'm just, have you ever had the flu?
Yeah.
When you really had a really bad flu and you put things in your mouth, things taste like what? I don't know, like nothing. You just eat it because, you gotta eat something, but not because nothing tastes bad, right? I mean, everything tastes bad. All right, so directs immediate response to every single stimuli. So again, to the environment that is changing, coordinates and moderates activities with not only one, but every single system. It provides and interprets all sensory information, right, out of the external conditions. So that's what allows you to know where you are, what you are, right, who you are, and what would you be.
What sense is like the one that the brain remembers the most?
The brain remembers the most?
Yeah, what sense?
There's not actually a specific one. It depends on the individual and what type of use do you give it. So I saw once, what is it, a science channel? This guy was he actually gets paid, I don't know if that or not, $500,000. For what? Taste. That's all he does, taste ice cream. He has a really developed, right, cute taste receptors, and he gets paid that much. He's the, I don't know, taste man. So the other individuals that have a really good hearing sight, right? I mean, the best ones are ducks, right? But we're not ducks, right? Even though we behave like that sometimes, but no. It depends. Some people are really good smell. Like me, for example, I have developed through years. I'm a foodie. So every time I taste something, I would like to know what is inside, like what condiments are in the food. So if I were to taste something, I could tell you almost all the condiments that are in there, because I've been trained like that. So, but it depends on what you're doing at the moment or what you focus on. So the endocrine system, this system is not part of anatomy 1, it's part of anatomy 2, but it's a fair game in biology, right? So endocrine system is the next system in the level of hierarchy. So the first one in hierarchy is your nervous system. The second one is your endocrine. So this one as well regulates the rest of your body. You have pituitary gland, thyroid gland, pancreas, renal glands, gonads, right? All the other ones. So please feel free to read over these ones. I'm not going to spend a lot of time in these ones because we're not going to cover it, but you may have like 1 or 2 questions on the exam on it. Okay, so just feel free to do it. Okay. How are we doing on time? Huh? Okay, so we can do homeostasis. So homeostasis, what is homeostasis? You control temperature, you control everything. So homeostasis is the steady state. What is a steady state? Like a state that your blood pressure is neither high nor low. Is actually what? Normal. 110/7. Does that make sense? That's homeostasis. The way I remember homeostasis is home. Out of my home, I feel good, and I stay in my home. So it's a level of that body, every single body measurements of temperature, ions, calcium, phosphorus, magnesium, blood pressure, everything is leveling up at normal levels. Remember, all these things inside our body are changing, okay? So it's the ability of humans to maintain a relatively stable internal conditions, like for example, temperature, pH, fluid balance, etc. How do you regulate your amount of fluids? If you drink too much water, what do you do? Do you really use that all the time? You can drink a lot of water and you can just run and just sweat like crazy and then you don't have to urinate, correct? All right, you can just vomit a lot and you really become really thirsty, so you get more water. Why are you thirsty and why do you need water? Well, water is the most component of our body, right? It's about 65% of our body weight. So 60, 65. If you're a neonate, a new child, right, then that can get up to like an 80%. That's a lot, right? So it ranges with a 70, 75. So in other words, water is also needed because water is part of your blood vessels. Of your blood, which is inside your blood vessels. So the more water you put in your body, if your body absorbs the water, you can get more of a blood pressure. Does that make sense? Because water is part of the blood. If your blood pressure is too high and your body does everything to dilate, but your blood pressure increases, what do? You pee it out. One of the 2 ways, right? You poop it, right? You vomit it, or you perspirate it. Normally, right now, you're losing water. Through what? Through breathing. If you don't believe me, put your hand right here. And feel that there's humidity in the air that you're breathing out. So you're losing water. That's how your body does it. All right. So pH, what is the normal pH of your body? 7. 7 is the pH of your body. It's actually 7.35 to 7.45. But we're going to talk about that later. So pH is the middle ground. Anything above 7, so anything greater than 7 is what? A base. Anything lower than 7 is a acid. That's it, guys. We'll leave it there for today. Have a good one. Good weekend.
Sorry, about the person of this class, what of the goal of the name it is?
Oh my god.
Because
Yes, I
there
know.
are three different.
I gotta send an email on that. I didn't do it. If you want, I can give it to you. I gotta create it.
Okay, and for this book has to
That's the lab.
yeah. In the lab is the other. It's Coneri. Coneri?
Yeah, and the lab, but I will give you those codes. I gotta build those codes, and I will send them an email for everybody.
Okay.
I can do that today. I have plenty of time.
And the book has to be new or no?
Whatever.
The code is a part of the book or the book comes with the code?
If you buy the book, which is $150 or $200, it already comes with a code. Oh, no, not this one. The one for the lecture. But for the lecture, as long as you have a source textbook, you're good.
Okay.
The code by itself on mastering on Pearson is like $60. So if you rent a book or get another book.
Yeah. And for this?
For the lab,
Mm-hmm.
you really don't need it because everything's gonna be on the PowerPoints.
Okay.
I will give you a review. But if you want to buy it, yeah, you can do it.
Okay.
So guys, tell me.
Good.